Okay, this is the second section in Module 12, Exponential and Log Equations. So in the previous module, we introduced these two things as functions, right? So an exponential function and how it looked like with a graph, log function, how that looked like with a graph. And then in the previous section, we talked a little bit about properties. And the reason that we introduced properties is because we're going to start solving equations. And so we'll just see how we solve these equations. There's a lot of different forms, so you'll see a lot of this on the exam. So just be aware of this section. This is a good section to kind of make sure you review well. Okay, so one of the first things with exponential equations, that's where we'll start with, is that you have scenarios where you're looking at an equation where both sides have the same base. And so, for instance, what you'll notice here is that you have 3 to the n minus 6 is equal to 3 to the 8n minus 4. And really what it boils down to, and that's what the general note says, you can basically drop the base, right? So what you're doing there is you can drop the base and just focus on the equations. So the two equations in the power are equal. Now the reason that that's true, and I'll just state this now because it comes up a little bit later as useful, is that what's going on is you're actually taking the log base 3 of both sides. So I'm taking the log base 3 of this left and the log base 3 of the right. And when you do that, your log base 3 of 3 drops out, right, because they're inverse relationships. And you just end up with n minus 6, right? But a really simple way to think about it too, again, and that's how I would, is if the base is the same, just drop them. So this will leave me with n minus 6 is equal to 8n minus 4. Okay. And then we can solve. So if I move over that n and move over that 4, so I'll end up with negative 2 is equal to 7n, or n is equal to negative 2 over 7. Now, with exponentials, there's no restrictions on on your exponentials, so n can be anything in this case. And in any exponential equation, you usually are not restricted, but it's always good to check your solutions just to make sure. Now, in certain cases, you get scenarios where the bases don't look the same. And so what you could do is try to work with the bases so that they are the same. So for instance, 27 is 3 cubed. So I'm going to write this as 3 cubed to the x. 243, I'm trying to remember what that breaks down to. 243 divided by 3, it's 81. So 3 to the 5th. So this is 3 to the 5th here. If I simplify a little bit more, so notice that we have a rules of exponents, so a power to another power, you can just multiply. So this is 3 to the 3x is equal to 3 to the 5th. And just like last time, you can drop your base, right? So here, if I drop my two bases, I just have then that 3x is equal to 5, or x is equal to 5 over 3. Right, so those are nice. If the bases don't look the same, try to make them look the same. And if the bases are just the same there, you drop them, right? So that's so far so good. Again, sometimes you have a scenario where the bases don't look the same, but you can try to work with it. For instance, here, 1 over 10, that could always be written as 10 to the negative 1. So you could now get closer to solving these two equations with the same base. Take a minute and try to see if you can figure that out. Pause the vid and see if you can work that out, and I'll do the solutions afterwards there. All right, so there's some scenarios, though, where you can't get the bases to be the same. And this is the one, right? So if you look at the two sides, 4 you could write as 2 squared, but 13 doesn't break down to anything nice. So in those cases, what you really can do is just take a general log of both sides to help simplify a little. So I'm going to take the log of the left and the log of the right. The reason I'm doing this, it doesn't look any nicer, is we have a rule that states that powers can come down, right? And there's a power of x minus 2. And so we have a log of something with a power, the power comes down. So that's what I'm going to do. I'm going to use my rule here. So here, that rule, to state that the x minus 2 comes down and I just have the log of 4. Now again, it doesn't look nicer, but what you can do is work with this. I'm going to divide that log of 4, that's just some number, right? Right, so on the right side, I have log of 13 divided by log of 4. I'm going to add 2 to both sides, right, because I'm solving for x. I can do that now that x is out of the power and in the base. And I have an answer. Now, it does say to approximate to 4 decimal spaces, so what we can do here, like grab that handy-dandy calculator. So 13 log divided by, was it 4 log? Yeah, 4 log. Do parentheses 4 log, close parentheses equals. And then I'm going to add 2 to that, so plus 2. So I get 3.85. Now they said 4 decimals, so 3.8502. There. So this is equal to. So that would be my answer. So again, if you can't get the same base and they're asking for a solution, you can approximate. And usually it tells you to approximate, so that's a key to get your solution. This is again one of those, right? Now in this one, when you're trying to solve, you could do log of both sides, but another common base is natural log, or sorry, e. So you could take the natural log of both sides. So take the natural log of both sides and see if you can come up with your answer using this one. And I'll pause the vid and come back to the next one. You can check out the solutions. Now this one here, again, the issue that you're running into, you've got a same exponent and same base, but you've got one term, that 3, that doesn't have anything to do with e. So in cases like those, try to see if you can put together common terms. So for instance, you have an 11e to the 13, you have 4e to the 13. Maybe move over that 4e to the 13 to the other side. All right? Because what you can do there, you've got common items, right? You can add those together to get 7e to the 13t is equal to 3. And this puts you in a very similar scenario as last time, right? If I divide that 7, now I can solve, right? So take a minute and solve that for t and approximate it to 4 decimal spaces. Oh. Now this last one here is interesting, or not, depending on how you want to think about it, just because it doesn't have the same power. It's got the same bases, right? But they're separated by addition and subtraction, and they have different powers. So you can't put them together like you could the last one. So this one's trickier. And the way to solve it, I'm going to move everything over to one side. Right? So this is kind of the unusual one, but you will run into it. And what you'll notice here is that you can sort of make those powers the same. I'm going to do that by taking out that 2. So I'm going to write this as e to the x squared, right? It's almost going backwards from one of the exponent rules that we had a minute ago. And then I'm going to give myself a parentheses around that e to the x just to kind of emphasize that there is an e to the x in one place and another. It's just one is squared and one isn't. And what this allows us to do is introduce a substitution. And in substitution, we talked about this super briefly back in the beginning, probably module 3. And so what you substitute with is whatever term is squared. So if e to the x is squared and then you have that e to the x there, I'm going to say let u equal to e to the x for a minute. So I'm going to write this as u squared minus 3u minus 4 equals 0. Right? So basically I've replaced those e to the x's with u's. The reason I did that is because now it looks quadratic, right? I can work with that a little easier. And so I can factor, right? Just like I normally would with quadratics. This looks like it factors to u minus 4, u plus 1. and I'll have u minus 4 is equal to 0, u plus 1 is equal to 0, or u is equal to 4 and negative 1. Right? So that's great because it allowed me to work with something I'm more familiar with, but you've got to go back and substitute again. So now you've got to back substitute. And when you do that, you're saying that e to the x then is equal to 4 and negative 1. Now let me separate that a minute. So e to the x is equal to 4, and e to the x is equal to negative 1. Now we've solved those in previous scenarios. We see how to solve, right? If I take the natural log of both sides, I'll get that x is equal to the natural log of 4, and x is equal to the natural log of negative 1. And those are your answers. Now, do be careful. Now, before when we talked about, like your answers, with exponentials, your answers can be anything. There's no restriction. So it's usually, assuming you're doing all the work right, usually that's it. But once you get into natural log or any log territory, you have to make sure that you're taking the log of a positive number. We've stated before that the domain of log of x, for example, is always positive numbers from 0 to infinity. So that value, natural log of negative 1, if you plugged it in your calculator, would not work. And so we do need to remove that solution. And so our only solution then is this natural log of 4. So again, this is a little trickier. Just be careful with it, is all. Lots going on in there. Okay, now we're looking at log stuff, right? Log equations. So with log equations, same idea in terms of how to solve, but with a log equation, you don't really have the same base or anything like that, right? So what we're going to do first is just isolate the log, right? So if I see that I have the log base 4 of x plus 2 is equal to 6, let me move over that 2, right? Let at least get the log by itself. So this is going to be log base 4 of x is equal to 4. Now what you want to do is you want to get rid of that log. The way that you can do that is take that to the power, meaning that you're basically raising both sides with a base of whatever the base of the log was. So if it was log base 4, I'm going to do base 4. If it was log base 2, I'll do base 2. Same thing. Natural log, do base e. But doing so, remember log and the exponent are inverses of each other. And so those two sort of cancel out. I use that word informally. And so what you get here is x is equal to 4 to the 4. Right? And so that's your answer, right? You get your answer there. Again, you want to make sure that you get a positive answer because you have to be able to plug those in to check. But 4 to the 4 is definitely positive. Same idea here, right? First, isolate the log. So I'm going to divide that 2 to the other side. So the natural log of x plus 1 is equal to 10 over 2, or 5. And with natural log, what I'm going to do is take both sides with a base, or raise both sides with a base of e. Because e and natural log, they're inverses of each other. So on the left, I'm left with x plus 1. On the right, I'm left with e to the 5. And so my answer is e to the 5 minus 1. You could approximate it, but notice it doesn't say to do that. So when it says just solve, that's all you're doing is you're solving, right? Nothing else. If it does say approximate, then you would approximate. There are some occasions where you have the natural or the logs to be the same. And so kind of like what we did before with same bases on both sides, if you have the same log on both sides, just drop the logs, right? So I can say that since both of these logs are the same, I'll drop them. So x minus 7 is equal to 2, or x is equal to 9.